Welcome. We are still continuing with unit number 9, Selection Program Control Structures. In our previous video, we looked at if statements, and there are 3 forms. The basic if statement, which is useful when we have only one option. The if-else statements, useful if we have 2 options, where we can take either first option or the second option based on a single condition. The third form is if-else, if statements, and this one is used if you have more than 2 options. And we also noted that if-else if may optionally end with the else statement at the end, of course. In this particular unit, as we continue with the selection program control structures, we are going to look at the switch. A switch statement is another form of a selection constraint or selection program control structure. A switch is used if we have multiple options and we want to have one option. But a switch, in most cases or generally, is not used. We don't use it to get the option based on some condition, but we get the option based on some value. We should remember that from what we covered before, we were getting some option to say let's execute the block 1 or block 2 or block 3 based on some condition when we are at if statement level. So we could evaluate a logical expression. That logical expression would give us true or false, and based on true or false, some block of code would be executed. Here, we are not executing something based on some conditions, true or false, no. But here we are looking at a value generally. So it can be any value. It can be logical expression because true or false is also a value. But we are not limited to logical expression. It can be any integer, maybe 1, 2, 3. It can be any character, maybe A, B, C, D or something. So that if there's any value that matches that, maybe there's 2, then we are going to be using that 2 to check option that matches that. So we use a switch statement in that case. Here we have a structure in a pseudocode form of a switch. We give it a value. It can be logical expression, it can be a character, or just integer. We give it a value. And now we take that value and check that value against what we call cases, or against the options. So the first option is called case, and we put the value. What value are we going to match against this? So we can have multiple values, and each value or multiple cases, each case will have a different value. And the value that we are receiving, which is called a case value, will be checked against those values under each case. If this value matches value that we put here, then statements under this will be executed. If it matches this, for example, maybe the value that we gave it is 1, and here the value is 0, then it will not match that, but it will match where there's 1. Suppose value 2 is 1. Then it will match 1, and statements under that case will be executed. If this value does not match any, maybe this was a negative number, and all our values here are positive numbers, then our case value, our testing value, will not match any case. And in that case, the default case is executed. So the default case here can be considered as the else part of if statement. So this will only be executed if all these cases have failed to match the case value. So that's a switch statement. You are also required to come up with a flowchart for a switch statement. Going forward, we have conditional operator. A conditional operator is a ternary operator. By ternary, we mean it's an operator that is composed of 3 parts. Most operators that we have are binary, maybe an operator to add 2 numbers, the plus operator, minus operator, and those other arithmetic operators are binary. But we have also unary operators, those which only require one operand, like maybe an increment or decrement operators. They are unary operators. The not as in a logic operator, not is also a unary operator. But this is ternary. So we use it as a shorthand for if-else statements. If we have simple if-else statements, we can convert them into a conditional operator or conditional expression. And how we write it is as follows. The first expression here is a condition, and we separate the first expression and the second expression with a question mark. So it's like we are trying to ask, is this true? Is this what we put here true? So if that one is true, then this should be executed, else this should be executed. For example, we can have x is less than 0. We are trying to ask the value that is in x. Is it less than that, less than 0? Is it a negative? So if this is true, then we are saying, then take 10 and put it into a variable y. Else, if it's a positive, that is, or 0, then we want 20 to be put into z. So this is just something that we are using to demonstrate the concept. But the point is, when this one is true, something should happen. If it's false, something should happen. And those two are separated by column. Here we have another example, how we can convert this into if-else statement. So this statement can be written, if we are to expand it using if-else statements, we can write it like this. If this is less than 0, then y is 10, else z is 20. Or sometimes we can have something as this. So we can have this part, which is a condition, x greater than 100. If this is true, then 0. If this is false, then 1. So we are returning 0 or 1. And this thing that we are returning can be assigned to a variable. So we want our variable a to be 0 or 1 based on some conditions. If x is greater than 100, then our a will be 0. If it's not, then our a will be 1. So this can be rewritten as here using if-else. So we can say that this is a more compact, simple way of writing it as compared to this. It will just be written in a single statement like that. So you may see these more often, but they are more applicable, or they are used for simple if-else statements where we don't have multiple statements. Like in this case, we are just trying to make a decision to say, okay, if something is greater than 100, then a different value should be assigned to that, else a different value should be assigned to that. So this is a simple if-else statement. But if-else statements may have multiple statements inside of them. So we may not express them using conditional operators. The purpose of having if statements, or maybe purpose of having the switch statements, is to help us make decisions so that our program can make a decision. And some of the decisions that can be made by our program is as, for example, validating user input. When we ask user to enter something, we may want our program to be checking if that user has entered that thing correctly. Maybe we are asking a user to enter a grade. So our range of grades maybe is from 0 to 100. But we cannot control what the user is going to enter. A user may want to enter something. Maybe may want to enter 200. A 200 is not an acceptable number. A user may want to enter a negative. It's not an acceptable number, but we cannot control it. So it's up to us to use the if statements and other, of course, the control structures, maybe if statements or switch, to determine if what the user has indeed entered is correct. Sometimes you may be presented with a form to enter maybe your details, and they are asking you to enter, for example, to enter maybe email address. Instead of writing email address, you may want to just write the stories about your background. Maybe you may start writing there, I was born in 1995, blah, 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 and all that information. But we said enter your email address. So we cannot control the user. We'll be there with the system entering whatever she wishes to enter. And if that happens, what should we do? We need to check if the information that is entered is correct. So mostly we use if statements to filter user input. If we are asking you to enter, for example, a PIN, we need to check that that PIN you are entering is correct. So we are validating user input. Some input validation would be numbers are checked to ensure they are written within a range, or values are checked for their reasonableness, although it might be possible for a person to be working for 168 hours, for example, in a week, but it is not probable. So maybe we are asking how many hours did you work last week, and somebody enters 168. What it means is he never slept. He was working each and every hour. So although this number is okay, that in a week we have 168 hours, but it's not probable. Items selected from a menu or some other set of choices are checked to ensure they are available options, for example, and variables are checked for values that might cause problems, such as whether that value would result in true division by 0. C++, specifically, or other programming languages as well, of course, allow programmers to create their own data types. We are going to look at how we can create our own data types even next semester, but one way to do that is to use the enumerated data type. And this enumerated data type, we can just have it as a programmer-defined data type. And this particularly has got a set of named integer constants. So it's a programmer-defined data type which is consisting of integer constants. For example, we can create that enumerated data type using a num roster, and in curly brackets with a semicolon at the end, we can put those constants that we want to indicate. So here we can now use this, for example, to say roster student equals Teresa. Then we can say cout student. Or sometimes we may want to put some values associated with those constants. So Tom is given a value, because if we don't put these things, these constants may start from 0. So you can try it out and see what this one is going to give you. 0, 1, 2, 3, Teresa is on this position. So if we say our student of type roster is given Teresa, what would be the value of student? If we display student, what will be given out? And here we've made some modifications, of course. Tom is given 3, Shalom is given 5, etc. And here we are saying, can we display Tom? And what are we going to have if now we display Tom? What will be the value? So enumerated data types are used in most cases to group things that probably we are not going to be changing. They are constants, and we just want to define them and use them throughout our program. So they can be maybe, for example, an enumeration for the days of the week. So we want our days of the week to start from Monday, and we want Monday to be 0 or Monday to be 1. So we can have Monday equals 1, Tuesday equals 2, all the way to Sunday. And we, instead of using maybe 1 etc, we can just be using now Tuesday. Wherever we use Tuesday to be as good as we are using 2. The same with months. Months are things that will not change. So maybe January to December, we can put them as a enumeration. So enumerated type of months. So the data type will be months. And what is going to contain are those items such as January, February, March, etc. all the way to December. So when we want to have something, we can just say maybe a month of January. So by doing so, we are trying to avoid using something that is not available in that particular list, because we have given it a scope to say a roster is going to have only these guys, or maybe a month is going to have only 12 elements, and whatever we are giving it should be something that is in that particular roster. If, for example, here we try to put a value, here we have Teresa, but we try to put a value that is not contained up there, it wouldn't work to give you an error. But here is accepting Teresa, because Teresa is indeed a member of a roster. You are required to read more about enumerated data types. It is important for you to know about these things, but as we go on with our journey of C++, you are going to be meeting more and more scenarios where you are going to use enumerated data types. But it will be important for you to try these things out. Make sure you at least understand how to use the enumerated data types at this point. So find an appropriate scenario or scenarios in which you might need to use enumerated data types. State the weakness, if any, on using enum, and make sure you are able to use enum in C++ program. Okay, that's it for unit number 9. But here we have a number of to-dos that you can try out. Here's the first program that you can try out. Write a program to evaluate a function f of x and y for any two user specified values x and y. The function f of x and y is defined as follows. So it's accepting those two values, and it will add them if x is greater than or equal to 0 and y is greater than or equal to 0. It will square y and add it with x. If x is greater than 0 and y is less than 0, it will square x and add it to y if we have this condition, or it will square both of them and add them if x is less than 0 and y is less than 0. So that's the first to do. The second to do, we have it here. A program that should read a numerical grade and assign a letter grade to it according to the following table. So if somebody's scores has got a grade of something above 95, should be given A grade of above 86 but less than or equal to 95 should be given B. A grade of above 76 to 86 should be given C. A grade that is above 66 to 76 should be D, and any grade that is 66 below should be given an F. And another one, we want you to try out a program that should calculate average cost per mile for a given number of miles. So the cost per mile for a rented vehicle is 300 for the first 100 miles, and 200 for the next 200 miles, and 150 for all miles in excess of 300 miles. So we want you to write a program that should determine the total cost and the average cost per mile for a given number of miles stored in variable distance. So that's it that we wanted to share with you in this unit, and make sure you explore and see how you can implement if statements, switch statements, and enumeration in C++. Be comfortable with them and be preparing for end of semester examination. Thank you.